All right, hello everyone. All right, so today we're going to discuss um, week five topics, okay, which has to do with the rules of exponents and polynomials. All right, so let's get started. All right, so let's look at what is an exponent, right? So an exponent is basically a repeated multiplication. Okay, it's just a repeated multiplication. So, for example, if I have 2 to the power of 3, this is the base. 2 is what we call the base, and 3 is what we call the exponents. And the exponent tells the base how many times it has to be multiplied, right? And it tells the base it has to be multiplied 3 times, so it's 2 times 2 times 2. That's it. And that's going to be 8 at the end. Okay? All right, so it's kind of the same thing, but the first problem here we have to be careful because there is a difference between I'm going to put it here, negative 3 to the power of 4, and I'm going to put negative 3 in parentheses to the power of 4. There is a huge difference between those two because these two problems have different outcome, okay, or answer. All right, so let's start with this one, for example. So here we have the negative 3 in parentheses. So therefore, the 4 here, the exponent tells negative 3 has to be multiplied 4 times. So it's going to be negative 3 times negative 3 times negative 3 times negative 3. Okay? And then the end, you get positive, right? Because you multiply that negative number 4 times, it's going to become a positive number, and it's going to be positive 81. Okay? However, this one here, the exponent tells only 3 that it has to be multiplied 4 times. Not the negative. Not the negative. Okay? So, not the negative. Only the 3 is being multiplied 4 times. Okay? You can view this problem as being the same as negative 1 times 3 to the power of 4. That's exactly the same thing. This is the same concept. Only the 3 here is being raised to the power of 4. Not the negative. The negative, you view it as negative 1 is on the outside and is being multiplied by 3 to the power of 4. So at the end, you're going to have negative 1 times 3 times 3 times 3 times 3. And at the end, it's going to be negative from the negative 1, positive negative 81. Okay? So two different outcomes based on how they are presented, right? So if you have something raised to the power of anything, if it's in parentheses, it's everything inside the parentheses that is being raised to that power or that exponent. But if there is no parentheses, is whatever the value that is under the exponents that is being raised to the power, that you have to multiply X amount of time, right? So for example, if I have 5 a to the power of 3, right? Only the a here is to the power of 3. Now this is basically 5 times a times a times a, right? Not the 5. You don't include the 5. If I have 5a to the power of 3, then you multiply 5a 3 times. Okay? Alright, so I hope you understand this concept. Alright, so let's move on. So here, the answer would be negative 81, right? Because it's negative 3 to the power 4. Only the 3 is to the power 4. So we just did it here. So we have it right. Okay. Number 2, we have a double negative, right? But here, you wouldn't do the double negative here, right? So it would be incorrect. The only thing that you have to do is view this as negative 1 times negative 4 to the power of 2. Okay? Then you have negative 1 times, and then the power is 2, so you multiply the negative 4 twice, so it's negative 4 times negative 4. That's going to be negative 1 times these two gives me positive 16, and at the end you get negative 16, negative 1 times 16. Okay? Alright, let's move on. All right, this is kind of the same concept, but since we're doing fraction, let's do this one. So again, you have the negative on the outside, you view it as negative 1 times, and then the negative 3 to the power of 4 is raised to the power of 3, so I'm going to multiply that 3 times, so it's going to be negative 3 to the power over 4, times negative 3 over 4, and the negative 3 over 4. Okay? Alright, so we have 4 negative numbers being multiplied. So my outcome is going to be positive. Okay? I don't need to be the plus, but my outcome is going to be positive. And now I can multiply the 3. 3 times 3 is 9. 9 times 3 is 27. Over 4 times 4 is 16. 16 times 4 is 64. So 27 over 64 is the answer, right? Because we have 4 negative numbers being multiplied, so therefore the outcome has to be positive. All right, so let's move on. Kind of same thing here, right? So we have a combination of, so here we want to do this first. We kind of use in the OR operation, right? So we're going to do everything that is exponents, and then we're going to subtract. So it's negative 7 times negative 7, right? So negative 7 times negative 7 minus negative 2 times negative 2. This gives me positive 49 minus negative 2 times negative 2 is positive 4 minus 4. 49 minus 4 is 45. All right, let's move on. Now we're getting into what we call the negative exponents. So when we have negative exponents, it's just a matter of rewriting it as a positive exponent. That's the goal. You never simplify a negative exponent and leave it as a negative exponent, right? So the goal is always to put it as a positive exponent and then simplify if you can. All right, so what is the equivalence of, for example, a to the power of negative 1? Okay, so to make it this positive, I have to rewrite the a here, right? So we write it as reciprocal, which is, what is the reciprocal of a? Is 1 over a. And wherever you see the a here, you're going to put the positive exponent, which is, you don't have to put it actually, but it's going to be a to the power of 1. Okay? So we're going to do the same thing here. I want the reciprocal of 3, right? And that's what? That's 1 over 3. And we're going to put that negative exponents as positive, and that's going to be positive 4. Okay? And at the end, it's going to be 1 over, and then if you know what 3 to the power of 4 is, you put it, it's 81. But if you have to work it out, you just put 3 times 3 times 3 times 3, and at the end you have 1 over 81. Okay? Alright, so a negative exponent does not result to a negative number. Okay? So just make sure you understand that. Alright. Unless the base is negative. But anyway, the kind of same thing here, right? You take care of the negative exponents, put it as a positive exponent. So what is the reciprocal of negative 2? That's 1 over negative 2. That's the reciprocal, not the opposite, the reciprocal. So 1 over negative 2. And then to the power of, and you can put the parentheses if you want, to the power of 1. You do not have to put the 1. If you want, you can. and negative 2 to the power of 1 is just negative 2. So my final answer is going to be 1 over negative 2 or negative 1 over 2. Same thing. All right, so a little bit more complex here. I want to give you a trick here. All right, so this is a good time to show you a trick. You notice that when I have a to the power of negative 1, the result is 1 over a, right? And the assumption is that the exponent of a is just 1, right? So if you look at a to the power of negative 1, it is actually a numerator, and we assume that it is over 1, correct? Right? So that's basically what it means, right? And so you notice also that a to the power of negative 1 is a numerator, right? And then its equivalence of 1 over a to the power of 1, a to the power of 1 is a denominator. Okay? So we can make the assumption that if I'm moving a negative exponent from a numerator to the denominator, what happened? The exponents becomes opposite. So it becomes from negative 1 to positive 1. And so also, if I had something like 1 over a to the power of negative 1, then if I follow this assumption, that means its equivalence would be a to the power of 1. And it is, with the assumption that it is over 1. Okay? So, I can actually, just without saying, if I'm following this process here, I want the reciprocal of a to the power of negative of a, I don't have to do that. All I have to do here is say, hey, make those positive exponents. So all I have to do is move the 7 to the power of negative 3 as a denominator, and it becomes 7 to the power of 3. And then the 2 to the power of negative 4 is a denominator now. Make it a positive exponent by putting it as a numerator, 2 to the power of 4. And that's it. Okay? I made them positive exponents, and then from there you can so 16, 49 times 3, 49 times 7, I'm sorry, is 343. Okay, so 16 over 343 will be the answer here. Okay, so that's a trick that you can use with negative exponents, right? And you might want to use it in certain cases. Now, in this case here, it's a little bit different. So you have a fraction raised to the power of negative 3. So you use the same concept that we used earlier, but now all I have to do is just a little bit different. So I want the reciprocal of that fraction, which is negative. When you say reciprocal, it does not change the sign, okay? So if you have a negative number, it's still negative. It's just that you're switching the numerator and denominator, and now it becomes negative 4 over 3. Put it in parentheses, and now the exponents becomes opposite, and so it becomes positive 3. Okay? And now you can evaluate, since you have a positive exponent, you can say negative 4 over 3 times negative 4 over 3 times negative 4 over 3. Okay, so we have 3 negatives being multiplied, so my result is going to be negative. You multiply across 4 times 4 times 4, that's 64. And 3 times 3 times 3 is 27, so that's my final answer. So that's that. All right. So let's just do one of them because I put 2 here of the same. So kind of say, so we want to rewrite this. right? So these two, those are negative exponents. So if I put it as a positive exponent, it's going to become 1 over 5 plus 1 over 7, right? You can say 1 over 5 to the power of 1 or 1 over 7 to the power of 1, same thing. And we know how to deal with fractions. So it's going to be 7 plus 5 over 35. And that gives me 12 over 35. Okay. All right. So that was for negative exponents. Now let's move on to the zero exponents. All right. So zero exponents. There's a rule for it, and the rule is very simple. It means that anything raised to the power of 0 is always equal to positive 1. That's it. Anything that a represent, it doesn't matter what it is, a value, variable, anything, if it's raised to the power of 0, except a, you cannot have a situation when you have a is equal to 0. So 0 raised to the power of 0 does not exist. Okay? Okay, so that's the only value that you cannot have as the base. Okay, so if I have 14 to the power of 0, that's equal to 1. That's it. It's as simple as that. I can have 1,359,005 to the power of 0 equal to 1. Doesn't matter what it is. Now, if you have negative 562 to the power of 0, again, we apply whatever we learned earlier. The power of 0 only applied to the 562, so the negative remains, and the 562 to the power of 0 is 1, right? So you view the negative as negative 1 times 562 to the power of 0, and that gives me negative 1, right? So that's what we get. Okay? And same thing that we've seen with other negative exponents or other exponents. All right, so just like I mentioned before, the negative is on the outside, and that's going to be negative 1. Okay? All right, so here we have 15 to the power of 0 plus 12 to the power of 0, right? This is equal to 1. Oh, I have to download something. Let me download it, because I need it later. Plus 12 to the power of 0 is also 1, so 1 plus 1 is equal to 2 at the end. Oops, sorry about that. Okay, let me minimize this. Sorry about that. All right, so let's do another one here. So here we have 7 to the power of 0. We know it's 1. Minus 12 to the power of 0 is 1. And 1 minus 1 is equal to 0, right? They cancel each other out. So it's 0. The value is 0, not the exponent. Okay. All right, moving on. Now let's get into the rules of exponents, right? And let's start with the product rule. All right, so the product rule says that if you have two exponents as such, a to the power of m, for example, times a to the power of n, because a, which is the base, are the same, now I can do what? I can add the exponents. So if I have the same base and these two are, they've been multiplied, then I can rewrite this as a to the power of m plus n, and then simplify m plus n. Okay, that's the product rule. So here, I can rewrite this as 10 to the power of 6 plus 8, because 10 is the base, and 10 is the base, and these two are being multiplied. And so that, at the end, is going to be 10 to the power of 14. Right? You don't need to evaluate this, because otherwise it's going to become a very long number, so you can keep it like this. So here it tells you, write the answer with the only positive exponents. All right, so here, let's look at this here. So you have 3, 3, and 3, right? Everything's being multiplied, so we can add all the exponents. So it's going to be 3 to the power of negative 10 plus 5 plus negative 1. We evaluate this, and that's 3 to the power of negative 10 plus 5 is negative 5. Negative 5 plus negative 1 is negative 6. So 3 to the power of negative 6, right? But they say that they want the answer as a positive exponent. This is negative. So therefore, we put that as a negative exponent. We view this as 3 to the power of negative 6 over 1. Make this a denominator. It becomes 1 over 3 to the power of 6. Okay? Alright, so that was the product rule. Let's move on to what we call the quotient rule, right? Now the quotient rule, kind of the same thing as the the product rule, but now we're kind of dividing, right? So multiplying. So again, I can put this a to the power of m over a to the power of n. If you have the same base, then you can rewrite this as a to the power of m minus n in that order, the m first, and then followed by subtracting the n, right? And then you simplify this and you should get your answer. So let's do the same thing here. So 5 and 5, same base. So I can do 5 to the power of 17 minus 5. And that's 5 to the power of positive 12. I don't have to do anything else. Okay? All right. So we have 10 to the power of negative 14 over 10 to the power of negative 3. If you have a choice, right? Because I'll show you the trick. If I showed you the trick and you remember, you're probably, oh, I'm going to put them as positive exponents first, right? 10 to the power of 3 over 10 to the power of 14. You can do that if you want, and then apply the quotient rule, just like we mentioned. That's one way of doing it. And let me continue on, and then I'll show you the other way. So, because they have the same base, I can write it as 10 to the power of 3 minus 14, right? Equal to 10 to the power of negative 11, I'm sorry. And at the end, I need to put this as a positive exponent, so it becomes 1 over 10 to the power of 11. That's one way of doing it. Let's look at another way. So I have 10 to the power of negative 14 minus, that's part of the formula because I have to subtract because this is a quotient rule. Let me put minus, right? And then negative 3, which is the exponent of the 10 at the bottom, minus negative 3. Okay? So you're going to get the same answer. So here is going to be 10 to the power of negative 14. A double negative make it a positive 3. Oops. Positive 3. And at the end it gives me 10 to the power of negative 11, which gives me, again, 1 over 10 to the power of 11. Okay? So two different ways of approaching this problem. All right. The next rule is called the power rule, right? So the power rule goes as follows. So you have a to the power of m being raised, an exponent is raised to a certain power, n. And in this case, you are going to multiply the exponents. So it's going to be a to the power of m times n. Okay? So if you look at it, if you kind of to break down, so if you have 2 to the power of 2 raised to the power of 3, for example, well, that exponent tells 2 to the power of 2 to be multiplied 3 times. So it will be 2 to the power of 2 times 2 to the power of 2 times 2 to the power of 2. And then the next step would be to add all those exponents, basically 2 to the power of 2 plus 2 plus 2, right? Which is same thing as 2 times 3, right? That's basically what it is, right? If you were to, so that's all it is, 2 to the power of 6 at the end. Okay, and we know that 2 to the power of 3, 2 times 3, I'm sorry, is equal to 6. Okay, so that's a shortcut. So you can do the same thing here. So here you have to kind of be careful because you have a negative exponents. Okay, but it doesn't matter. You got to put -2, and then you're going to multiply these two exponents, right? Actually, this one is a little bit tricky because you have to think, right? Yeah, this one is a little bit tricky because you're multiplying this -2 to the power 4 3 times, right? First of all, this part right here, -2 to the power 4, yeah, so -2 to the power 4 is actually going to give you a negative number, right? Because it's really -1 times 2 to the power 4. That's negative as a final answer. And then that negative number is going to be multiplied that negative number is going to be multiplied 3 times. Which is going to give me a negative number. Okay, so this one is a little bit tricky. But anyway, let's try to follow the product rule with this. Okay, so we have a -2 to the power of 4 times 3, right? And that's going to give me -2 to the power of 12. Okay, and that's it. You leave it like this, and you must leave it like this. Okay, because you don't want to put it as this, because otherwise the final answer is going to be positive. So leave it as it is. Okay, very good. All right, so now the next set of problems, we kind of doing a combination of the product rule, quotient, and power rules, right? So first, but we want our answer to be positive exponents. So here we're going to use the product rule. So on top here is going to be 10, and -6 times 5 is 10 to the power of -30, right? And then you have 10 to the power of -5. Now we use the quotient rule, and that's 10 to the power of -30 minus, I'm sorry, minus -5. So minus -5, and that gives me 10 to the power of -30 plus 5, which is 10 to the power of -25. Okay, we do not want a negative exponent. We want a positive exponent, so therefore it's going to be 1 over 10 to the power of +25. So that's your final answer. Okay, that's the approach there. All right, so here, there's different ways that you can approach it, but I'm going to approach it like do the top first and then do the bottom first. So if I do the top first, I have to use a product rule, so it's going to be 10 to the power of -5 plus 3, right? You have to add the exponents, over 10 to the power of 2 plus -7. When I simplify, I should get 10 to the power of -2 on top, over 10 to the power of -5 at the bottom. Okay. What I can do, I just want to do another approach. I want to make those positive exponents, because if I made them positive exponents, I'm going to have 10 to the power of 5 over 10 to the power of 2. I just want to have the exponent, the greatest exponents on top, and the smaller one at the bottom. And so now I can use the quotient rule and get 10 to the power of 5 minus 2, which gives me 10 to the power of 3. Okay, so that's that. All right, so that was the exponents, the rules of exponents. And let's move on to adding and subtracting polynomials now, right? So kind of the rule for adding polynomials is that you must have, first of all, the same terms, right? And what do we mean by terms, right? So if I have a 3x squared minus 5x plus 3, right? So these are terms, right? That's one term, that's another one, and that's another one, right? And so all three of them are not the same, right? They are different because even though the first two here we have the x term, but one is to the power of 2 and the other one is to the power of 1 and the other one doesn't have an x term, so it's definitely not the same, right? But these two here, the first two, they're not the same at all. So you cannot combine them. You cannot say, okay, well, 3 minus 5 and then write the x next to it. No, you cannot. Okay? In order for me to combine like terms, I must have, for example, 3x squared plus 2x squared. All right? So here I have x squared and x squared as a variable. So now I can add 3 and 2 and simplify this as 5x squared. Okay? So must have the same variable but also the same exponent in order to add or subtract. Okay? So let's do that. All right, so here I have to perform this thing here. So all I have to do is kind of combine the ones with the same term, right? That's it. So here I can do 5x squared plus negative 2x squared. So I'm just going to put plus and minus is negative, so minus 2x squared. And then the negative x plus negative 4x, so negative 4x. And then the last one, negative 6 plus positive 3, so negative 6 plus 3. Okay? So I can combine these two, and these two. When I do 5x squared minus 2x squared, that's 3x squared. Negative x minus 4x, that's negative 5x, and negative 6 plus 3, negative 3. And you're done, because now you can see that there is no like terms. And this is my final answer. Okay? So, right here, I can do the same thing here. But here we have to be careful because we have a minus sign in front of the other polynomial here. So here, you actually have to distribute the negative and change the sign of the second polynomial. So the first one is going to become the same, it's going to be the same, negative 6x cubed plus 9x squared plus 4 minus, well, it's not minus anymore because it's a double negative, so it's plus 5x cubed, right? And the negative times the positive is negative, so it's minus 2x. And negative times a negative is positive, so it's positive 5. Okay? So we are done here. All we have to do is combine like terms. So combine this with this. And then the positive 4 with the positive 5. And that's it. The x squared is by itself. The x is by itself because they don't have an exponent of 2 or 1. So we have negative 6x cubed plus 5x cubed plus 9x squared minus 2x plus 4 plus 5. So combine these two and then combine these two. So this is negative 1x cubed or negative x cubed plus 9x squared minus 2x plus 9. No like terms. We are done. This is your final answer. Okay? And then this one here, So you're adding these two, so it does not change the sign of this polynomial, but here I have a negative in front of this polynomial, so it's going to affect the sign of all those terms here. So let's rewrite it. So negative 5x to the power of 7 plus 2x9 plus 9 plus, I don't need to put the plus, I'm just going to put negative 7x to the power of 8 plus 6. And then here, everything changes because of the negative. So it becomes negative 2x to the power of 8 minus 6x to the power of 9 plus a negative times a negative, so it's plus 7x to the power of 7. Okay, now I can combine the like terms. So I'm gonna start with the highest exponents, which is the 9 here, and I'm gonna have 2x to the power of 9 minus 6x9. Then I'm gonna go to the eighth, negative 7x8 minus 2x to the power of 8, and then to the 7, negative 5x to the power of 7 plus 7x to the power of 7. And then after that, you have the plus 9 and the plus 6. So plus 9 and then plus 6. Okay? And so, let's simplify. So 2 minus 6 is negative 4, so negative 4x to the power of 9. Negative 7 minus 2 is negative 9, so negative 9x to the power of 8. Then this one here, negative 5 plus 7 is positive 2, positive 2x to the power of 7. And then plus 9 plus 6 plus 15. And that's it. Okay? So that was adding and subtracting. So now let's get to multiplying. Alright, so multiplying requires the use of what we call the FOIL method. The FOIL method goes as follows. So let's say you have x plus 2 times x plus 4, for example. Alright, so when you have two binomials and you're multiplying, you view the first terms as f, right? So FOIL method. So we interest in the first terms, the outer terms, the inner terms, and the last terms. Right? So the first terms are x and x. The outer terms are the x and the 4. So the 0, the O and the O here represent the outer term. The inner terms are the 2 and the x. So inner terms, 2 and the x. And then the last terms are the 2 and the 4. So we put L and L. Right? So when you match the f's and the o's and the highs and the l's, right? You multiply them. Here's what you get. You get x times x squared. The x times the positive 4 is plus 4x. The 2 times the x for the inner is positive 2x. And then the positive 2 times the positive 4 is positive 8. And then you simplify the middle term here, the 4x and 2x, and you get x squared plus 6x plus 8. And that's your final answer. Okay? Alright, so let's do the same thing with number 26 here. So the first term is the 3x and the 3x. So that's 9x squared. That's the first term. The outer term is, so let me put f and f, right? The outer term is the 3x and the negative 12. So 3x times negative 12 is negative 36x. So negative 36x. And then the inner is the positive 12 and the positive 3x, which gives me positive 36x. And then finally, the last term is the positive 12 and the negative 12. When you multiply them, you get negative 1. 12 times 12, 144. Okay? So, what do you notice? When you add or subtract the middle term, it cancels out, right? Negative 36x plus 36x is 0. So I'm left with 9x squared minus 144. Okay? And then finally, 4a minus 7 squared. So it's 4a minus 7 times, because it's squared, right? 4a minus 7. That's what it means. And so you multiply, right? First term, so f and f. That's 16a squared. The outer term will be 4a times negative 7. That's negative 28a. And then the inner terms is negative 7 times 4a is negative 28a. And then the last term is negative 7 times negative 7 is positive 49. Okay, not to confuse with the previous one, the middle term were opposite, right? Negative 36 plus 36, that's 0. But here, we do not have opposite values. That's the negative 28 and negative 28, which gives me what? Negative 56a. Okay, so it's going to be 16a squared minus 56a plus 49. Okay, that's the result for this. Okay, and that's about it. Okay, so if you have any questions, please send me an email and we will go from there, and I will send you a YouTube if you want. That's fine. Okay, all right, so